So for this question, very similar to number 4, I believe. Fixed number of trials, fixed probability, independent of edge, 2 outcomes. But now we're saying that there's 5 batches of 5 that are being selected at random. Right, and we need to determine average numbers. So this makes it a central limit theorem question for proportions. All right, specifically for a binomial distribution. So we need rules, we need formulas, right? So that's our next step. So mu sub p hat is equal to mu, which is equal to np. Sigma sub p hat is equal to the square root of p times 1 over p over n. Over n. Right, so n is 5, so 5 times 0.12 is 0.6. On top, 0.12, 0.88 over 5. Right, so count those numbers. So off screen, I'm just popping this into the calculator. Times 0.88 over 5. And we get a result of 0.145. Alright, so then the setup is going to be pretty much the same as what we did before. So now it's just a matter of crunching some numbers, so I'm just going to crank out the old bootleg calculator here if I can get it open. It's not really bootleg. I don't even know. No, it's emulator. It's legit. It's just slightly different. Different enough that folks don't like it so much, but it gets the job done. So alpha, I'll get my n over d. You would do alpha y equals, but 2.5 minus 6 over 0.145. So we got, oh, that's pretty, oh, it would be a pretty gnarly answer if I put the 0.6 in instead of a 6. All right, still pretty funky. All right, so 13.103. Approximately. All right, so just like I did with the other problem, I think it was number 4, I keep forgetting, but I'm going to store that in as A, so alpha math on your calculator, So every time I hit A, that number will come up. All right, and I'll do all the stuff with this one in a minute, but we'll get there. All right, so we're going to find the probability that Z is less than or equal to the 13.103. Now it's going to be practically 1, but we'll see how close to 1 it is. Sometimes it's so close to 1 that the calculator will just say 1, right? And it won't be, but we'll have to say that it's virtually 1. All right, so let's see what happens here. Second vars, normal CDF. This is the old school interface. So low bound, high bound. So A to B. Well, actually, in this case, it would be negative infinity. So it's like negative extreme to the A, and then 0, 1. That's what it would look like if you had to type it in separately. But in your TI-84s, you have the that nicer interface where you just put it in down the menu, and it basically comes up with this. But it says 1, but it's virtually 1. All right, so it's really not equal to 1, because it's not guaranteed. It's not a certain event or a certain outcome. It's damn near certain, but it's not certain. All right. Now for this one, the scaling on the bottom is going to be the same. So let me steal that. Kind of ran through that quickly, but this is just adding the 0.145 to each value. All right. I know this video is a little choppy, but I'm kind of working around fencing and hockey practices and stuff like that. That's all that stuff that you might have heard in the background. If you were wondering, that's what that was. All right, so this is going from 2 to 4, so all this stuff is out. So we're looking at, I mean, it would take a little bit more to get to the 2, or in this case 1.5, than just a couple of standard deviations or standard errors, so it takes a little bit. But it's essentially going to boil down to, just something in this outer fringe here. I don't know how far it'll go, but I know it'll be something in this little tail region here. All right, so graphically, it's telling us that we're looking for something extremely small, so infinitesimal. All right, so go back to some previous computations, make my 2.5 into a 1.5. So on the ordinary TI, you would do second enter or just scroll up, but ultimately you'll get the same thing. So 6.207. And then for the next one, this emulator is nice. It does some things better. Like the touchscreen aspect is cool because you just touch on the thing you want to duplicate, but it's not a perfect fit for what we do in class, so apologies for that. So 0.897. All right, and so what we're looking for again is the probability that Z is going to be between these two numbers, 6.207 less than or equal to Z less than or equal to 26.897. All right, so belatedly I realized I should have stored, so I'm going to store it. Alpha math, but I have my QWERTY pad here. Store. Set the wrong thing. Alpha, it would be the key right next to math on your calculator, so whatever that is. So most likely apps, but my memory is a little fuzzy right now. All right, so second vars, normal CDF, A to B. Mean and standard deviation default to 0 and 1 on your calculators. That's automatically populated, so you don't even have to mess with it. But we get this number, so approximately 2.702 times 10 to the negative 10th power. So the part A here was virtually 1. This one could almost be interpreted as virtually 0, even though it's not the polar opposite of part A. It is in spirit. All right, so there we go. And it looks like there's a, we'll take it as a typo. Probably should have given a little bit more space for number 12. If I had to go on a separate sheet of paper, that probably is a good indicator that more space was needed. So first come, first serve on that. All right, and so there we go.